All right. So, one of the most important physical properties in chemistry is density. Now, density is defined as the ratio of mass per unit volume. All right. There's a simple formula for density. Density is equal to mass over volume. Now, something that you'll learn that anytime we have an equation, anytime, however many variables there are, that is how many different equations you will have in total. So right now, this equation is rearranged to solve for density, but there are going to be times where you have the density value and you have one of the others and you need to find the third. If that's the case, no big deal, right? Because let's say that I wanted to solve for mass. If I wanted to solve for mass, I would just multiply both sides by volume. Because then the volume times the density is how I would get the mass, right? So you're rearranging the equation to solve for different variables. And this is something you're going to have to do often, right? Let's say that I wanted to find the volume. Well, something that you probably should have learned in math is that if there's a variable in the denominator, you don't solve for it when it's in the denominator. You've got to bring it up to the other side first, and then you can isolate the variable. So if I want to solve for volume, what I would do to this equation is I would divide both sides by density. And then V would equal to mass over density. Right? So manipulating equations is very important. You need to be able to do this well. Okay? You need to be able to do this. You need to practice this. If you want more practice on this, there is a worksheet. It's called Math Warm Up. It's in the homeworks folder. It's the first one, and the answer key is there. You should try doing those, and then check and see how you do. Right? If you need extra help on that, you should come and see me because this is very important. Right? We can't get hung up on not being able to solve a problem because we're not rearranging equations properly. Okay. All right. So density, 3 variables. Now, because the units on mass and volume both vary, you're going to see lots of different units. You might see grams per milliliter, you might see grams per cubic centimeter, you might see kilograms per liter, pounds per cubic foot. I mean, any unit for mass could be used, any unit for volume could be used. So you got to be able to convert from one thing to another, which was the whole point of the last class, to learn how to convert units, especially dual units. Okay. So, what kind of problems are you going to see? Well, you could be given the density and volume, and you'll need to find the mass. So, if we need to find mass, remember we already rearranged that, right? So, we'd say volume times density is how you find the mass. Or you might be given the density and the mass and need to find the volume, right? So, if that's the case, the volume is going to be the ratio of mass over the density. Or you might be given the mass and the volume to find the density, which is our default equation. Now, density, well, oftentimes when we find the density, we can get a possible identification for the material because the density of elements is unique. So if we find the density for one metal, we can look up what the metal's value is and we can make a match, right? So that's one useful aspect of solving for density. So here I have a bunch of sample problems, and we have the answer already given here, but the point is not the answer, the point is the process. So find a volume of a sample of copper if the mass is given and the density is given. Okay, so if density is equal to mass over volume, and remember we want to find volume, so that means volume is equal to mass over density. I'm going to take my 35.01 grams and I'm going to divide it by 8.96 grams per milliliter. All right, so numerically, when you look at these two numbers, we are dividing, and so from division, you know that the number of sig figs is limited to whichever number has the fewest. The first number has 4, the second number has 3, so our answer can have 3 sig figs. The answer is 3.91, but I want to talk a little bit about the units. If we just look only at the units, this is what we see, right? So in order to figure out what unit you really have at the end of that, whenever you have a fraction in the denominator, you can easily think of it as multiplying by the reciprocal of that fraction. Do you guys see that? Whenever you have a fraction in the denominator, pull out that fraction and flip it. And the reason why we do that is it becomes very clear then that the grams are going to cancel and the only unit you're left with is milliliters. Okay? So that's kind of an easy way to show how you arrive at the units that you have. And if you the more you do this, the easier it'll get. So our unit is milliliters. Okay, let's try another one. All right, a cylinder of metal has a radius that's given, and they give us a height, and they give us the mass. We want to find its density. All right, so if density is mass over volume, and if the mass is given already, right, the mass is given, in order to find the density, we need the volume. So we have the equation for the volume of the cylinder, and we have the radius and the height. So we need to determine what the volume is, and we'll substitute. So volume is equal to pi. And when I say pi, guys, don't type in what you think pi is. Just use the pi key on your calculator. Okay? Like, just, you might know pi to 5 or 6 or 8 digits, but just use the button. Right? Everybody know where the button is? It's on the right-hand side. It's a secondary function of the caret. All right, so pi times the radius, 0.97 centimeters, which will be squared, times the height, 3.75 centimeters. Okay, so pi times 0.97 squared times 3.75. Okay, so the volume of the cylinder comes in at 11.08471698. Okay, now I am carrying out, when I calculated the volume, the type of operations that I used were exponential squaring and multiplication, right? Everyone see that? So the next operation, when I take this volume here and when I insert it here, the next operation will be division, but division and multiplication are considered the same type of operation. So what I'm saying to you is that this whole number here, I am not going to round that. Because when you're doing the same operation types, you don't stop and round in between. You just round once at the end. So in my calculator, I type in 31.57, divide, and then answer, which is second negative sign. And that will give me an answer, and that's the one that I will round. So the density of it will be 31.57 grams divided by the whole thing. Do you guys know what I mean when I say second answer? I just carried out the operation in my calculator, and I want to reuse. It's almost like I want to cut and paste that number. So I typed in 37.15, divide, and then I hit second sign, or the negative sign at the bottom, and it should say ANS, and that means it's going to reuse the number that it just displayed. All right, you could retype it manually, and that would work the same way. It's just more work, right? But I just find this like a tool of convenience. Okay. So I did not get that. Did I make a mistake? Hold on, let me check my numbers. This ended up being, I got 3.35, but apparently that's not right. So let's double check. 0.97 squared times pi times 3.75. 11.0847. Okay, so 31.57 divided by that value. Okay, I just miscalculated the first time. I get 2.848065. Now I am at the end. Now I can round. How many sig figs am I allowed based on all of our original measurements? 2. Right here. 2 sig figs. So that's why it's 2.8 grams per cubic centimeter. Okay, so question. Let's say that you didn't really get that whole second answer key thing and then transplanting the number. You probably will still get the right answer, right? That's just kind of like a convenience thing, right? But
Isn't it 2.9?
I got 2.84.
I got 2.884.
What did you guys get? Yeah, you might have mispunched a number. Okay, so you'll need to find the density, but a lot of times you'll need to find the volume first. Okay, the equations for volume will be given to you, right? I mean, you probably do remember the volume for the simple shapes, right? Prisms and spheres and whatnot, but we'll give you those equations, right? The point of this class is not that, right? It's just to be able to do chemistry, okay? All right, let's try another example. So we have a graduated cylinder. It's filled with 20 milliliters of water. We use the same metal from last time. So the same piece of metal they're referring to here. Remember that they said the mass was 31.57 grams because it's the same piece, all right? The same metal is added, and the volume now goes up. What is the volume of the metal? Okay, so what they're describing here, this is what we call displacement. The displacement method. And what that means is you take a graduated cylinder, I didn't give myself enough room. You know what? Let me move that line. There we go. Take a graduated cylinder with some set amount of water. In this case, we were told that it's 20.0 milliliters, right? And then the object goes in, the piece of metal. And then afterwards, because it takes up space, the water level is going to go up. It's a pretty simple concept, right? So here's our metal cylinder in there. The water level is higher. The water level now reads 30.9 milliliters. So you can do this and you can figure out the volume. And all you need to do is take the difference. So 30.9 minus 20.0, 10.9 milliliters is the volume of the metal. So let's find the density. We need the mass over the volume. We have the mass, 31.57 grams. We have the volume, 10.9 milliliters. Now, while we're talking about using graduated cylinders, let's revisit again how we read measurements. Remember that you estimate between the smallest markings if you can. So if this was 19 and this was 20, and you always read the bottom of the meniscus, this is probably what they're saying. So if it seems like it's right on the line, you know there's 20 milliliters, but you are expected to estimate the tenths place, and that's why they said 20.0. Okay? Could you have said 19.9 or 20.1? Yes, you could have said those. Okay? All right. How does this density compare to the oh, wait, didn't actually solve for it. All right, so 31.57 divided by 10.9, 2.896330, blah, blah, blah. Okay, but how many sig figs can we keep? We can keep 3. So that means I'm going to drop the 9, but there's a 6 next to the 9, so that's going to round up. So this is not 2.89, this is 2.90. This is our volume using, this is our density using the volume from displacement. So real quick, let's take a glance back at the one we did prior to this. Our density this way was 2.8. And how did we arrive at the volume using this method? We calculated it. We took measurements, length measurements, and we plugged them into a formula, and then we calculated. But look what happened. Because we were measuring with a ruler, we were only able to get 2 sig figs out of the radius. And that's why our answer is 2.8 grams per cubic centimeter. Using this method, we were able to get 3 sig figs, because we were able to get a volume with 3 sig figs, and the 3 sig figs was retained as we carried out the calculation. So, how you measure initial data will have ramifications later to the outcome of a problem. Okay? So how does this compare? How does it compare? Well, 2 ways. It's slightly greater and 1 more sig fig. So if you were to have confidence, if you were to place your confidence in one of these values, which ones would you say? Which one would you go with? Second one, the one with more sig figs. The one with more sig figs is more likely to be correct. Okay.
0 has no value though.
What's that?
The 0 has no value though.
Sorry, what do you mean 0 has no value?
Oh, never mind.
Okay. Yeah, we'll do one of these, and then we'll switch gears and we'll talk about graphing. Okay. A waterbed. A waterbed is 8 feet by 7 feet by 0.75. Anybody here ever been on a waterbed? So waterbeds were really popular in the 80s. Every kid wanted a waterbed, right? So you lie down on it, and it's like you're floating on the ocean, right? And they're horrible for your back because there's absolutely no support. Usually what ends up happening is people, like, their back sinks to the bottom and their feet and their head are like propped up like a U. It's very uncomfortable, but it looked cool, right? And you loved having a friend who had a waterbed because you would hang out on their waterbed, but you were glad you didn't have to sleep on it. Does that make sense? Right? One of those things where it looks better in the store. Anyways, they were pretty popular. They don't really exist anymore, but let's do this problem. So we have a waterbed. These are the dimensions, right? So what they're implying by giving me these dimensions, length times width times height, is you need to find the volume, right? So of course you can just multiply and multiply all 3 dimensions and get the volume that way. So let's do that. Okay, so 42 cubic feet. They give you the density of water, 1 gram per cubic centimeter. How many pounds of water can fill the bed? All right, so how many pounds? Pounds is mass. They're asking for mass. So density is mass over volume, which means you'll be multiplying the density by the volume to find the mass. Now the density is given. We have the volume, but there's a little bit of a problem. My volume, the units are incongruent with my density, meaning the volume units do not cancel. What can you do if you have cubic feet, but you need to cancel cubic centimeters? Yeah, let's convert them. You guys know how to do this. So I'm going to add to this. All right, what do I know about feet?
12 inches.
Okay, a foot is 12 inches. Now, notice how this is cubic. Right now, if I asked you, does this conversion here cancel this unit, what would you say? It does not. It only partially cancels it. This conversion needs to be carried out threefold. Right? So this conversion, what I'm saying is I need to multiply 12 over 1, and then multiply by 12 over 1, and then multiply by 12 over 1. I need to do it a total 3 times because that's the only way that I'm going to cancel my cubic feet. Now, what unit would result by doing that? More specific? It's just cubed. So that process right here, this process right here, converts my feet cubed into inches cubed. Will inches cubed solve my problem? No, I need to do something else. I need to convert my inches cubed into centimeters cubed so that my centimeters cubed can be canceled, leaving me with the mass unit. Now, we're not quite done because they want the mass, but what unit are they asking for? Pounds. Okay, so what do I know about pounds? I know that a kilogram is 2.200 pounds, and my mass unit that I'm starting with here is grams. So I can go from grams to kilograms and then kilograms to pounds. All right, so let's do that. So a kilogram to grams, a gram is larger, or a kilogram is larger, it gets a value of 1. The relationship is 1,000. All right, so that will turn my grams into kilograms. And then the last step, kilogram is 2.200 pounds. All right, let's check for unit congruency, do some cancellations. So grams, grams, kilograms, kilograms. Okay, so I'm left with pounds, so that's good. All right, and then centimeter cubed, inches cubed, feet cubed. Wait, no, not canceling. Let's erase that guy here. Oh no, it is canceling. Yep. No, we're good. All right. Run the numbers. Okay. So multiply everything by the top, divide by everything on the bottom. Don't forget to cube the 12 and the 2.54. Two 616.476625. Where is our weak link of measurement? Any of the length measurements, right? The 8.0, the 7.0, the 0.75, each of those numbers has 2 sig figs. We are constricted to 2 sig figs. 2,600 pounds. That's over a ton of water in your bed. Granted, this is a king size waterbed. No kid had a king size waterbed. So let's just say even half that, right? 1,300 pounds. It's a heavy bed, right? And then the waterbeds would have this little spout. You connect a hose to it, and you let it run for like 2 hours to fill it. If there was a leak, right? Let's say you're hopping around on there, and like somebody's switchblade fell out of the pocket and like popped the waterbed. There'd be waterfall going down the stairs, right? Can you imagine why parents don't want this in their house anymore, right? Okay, you guys should Google waterbed or ask your parents about waterbeds. It's fun. Okay,